Today, we're going to dive into one of nature's coolest and, honestly, most sophisticated tools, the prehensile tail. Now, you might think a tail is just for balance, but it is so much more than that. For some animals, it's a genuine super limb that has totally changed the game for how they live. I mean, come on, you've totally been there, right? You're juggling your groceries, your keys, your phone, and you just think, man, I could really use another hand right now. It's such a classic human problem. But get this, nature figured out a solution millions of years ago. For a very special group of animals, this isn't some fantasy. Nope. They have a tail that's so skilled, so dexterous, that it literally works like a fifth hand. It lets them move through their world in ways that, to us, look pretty much like magic. And this is the prehensile tail. Okay, so let's get a clear definition here. The word prehensile actually comes from a Latin word, prehendere, which means to grasp or to take hold of. And that's exactly what it is. It's a tail that has evolved way beyond just being a simple counterweight. It's now a fully functional tool for grabbing, holding, and even manipulating things. So who exactly gets to be in this exclusive club? Well, the list of members is probably a lot more surprising and diverse than you're thinking. It really spans the entire animal kingdom. We see it in mammals, of course, like spider monkeys and opossums. We see it in reptiles, like chameleons. But here's the kicker. We even see it in fish. Seahorses use their little prehensile tails to hang on to corals so they don't drift away. So this is not just a primate thing, not at all. It's a really powerful evolutionary solution that just keeps popping up.
But it's really important to know that not all these tails are created equal. There's a spectrum. A fully prehensile tail, like the one a spider monkey has, is a true fifth hand. It can delicately pick up a piece of fruit. A partially prehensile tail, on the other hand, is more like a grappling hook. It's fantastic for anchoring yourself or for helping you climb, but it just doesn't have that fine-tuned control. So the big question is, how? How on earth does a tail evolve to be not just strong, but also sensitive and skilled enough to basically act like a hand? Well, the biological engineering behind it is it's incredible. And for the most advanced models, we're talking the luxury sedans of prehensile tails, like the spider monkeys. The real magic is all concentrated right at the very end. That last third of the tail is an absolute masterpiece of design. Let's zoom right in here. On the underside of that tip, there's a bare patch of skin. No hair. It's called a friction pad. And what's wild is that it has skin grooves, just like our fingerprints, which gives it a fantastic non-slip grip. But even crazier than that, this little patch is packed with super sensitive nerve endings, giving the monkey a detailed, rich sense of touch in its tail. Okay, so this is where things get really mind-bending. If a tail can be so much like a hand, I mean, it has fingerprint-like ridges and a sense of touch, could it possibly share another, even more complex feature with our hands? Exactly. Could a monkey be right-tailed or left-tailed? That's the exact question a group of scientists set out to answer. It sounds a little out there, but when you think about it, it makes a ton of sense to ask. Now, the official scientific term for this is behavioral laterality. It's really just a fancy way of saying there's a bias for using one side of the body over the other. And it's not random. It's a direct reflection of the brain's two halves being specialized for different jobs. Our own handedness is the most famous example. So the question becomes, can that apply to a single appendage, like a tail? So the researchers had this really clever hypothesis. They figured, just like with our hands, the key ingredient is probably the complexity of the task. They predicted that for a super simple action like just coiling the tail while resting, there probably wouldn't be much of a preference. But for a tricky, complex action that requires real skill, that's where a strong preference would show up. And this is exactly how they tested it. First, the simple task. They just watched which way the monkeys wrapped their tails when they were chilling out. That's what you see in picture A. Then they brought out the big guns, a series of puzzles, like getting a grape out of a tricky container, which you see in the other pictures. These tasks required real precision and control from the tail. And the results? Whoa. They were just unbelievably clear. For that simple resting task, you can see the preference strength is basically 0. The monkeys just quilled their tails left or right, pretty much at random. But for those complex, problem-solving tasks, the preference strength shot through the roof to nearly 100%. I mean, the researchers' own words from their papers say it all.
Skilled tail use, but not resting tail use, was highly lateralized. It wasn't just a quirk or a habit. It was the demand for skill that unlocked this hidden preference, totally confirming their hypothesis. But let's look at the individual data, because this is where it gets just stunning. This laterality index they used goes from -1 for exclusively left-sided to +1 for exclusively right-sided. Now look at Sunday and Mason. Perfect -1s. They were only using the left side of their tails for the hard stuff. And Uva and Kari, a perfect +1, exclusively right-tailed. The consistency is just off the charts. So, what does all of this actually mean? Okay, a monkey has a favorite side of its tail. Who cares? Well, this discovery is way more than just a quirky little fact about monkeys. It's a profound peek into the brain itself. The fact that these monkeys have tail-handedness proves this isn't just a muscle habit they picked up. No way. It is a direct physical sign of how their brains are wired. It's hard evidence of some seriously advanced neural architecture going on upstairs.
So why does this matter so much? Well, first, it shows hemispheric specialization. The two halves of the monkey's brain have divided up the work, which is a classic sign of a highly evolved brain. This division of labor makes the brain way more efficient. It's faster to have a go-to side for complex motor skills. And, thinking bigger beyond biology, this could literally inspire engineers who are building the next generation of soft robots. It's a perfect blueprint for a limb that's both powerful and incredibly sensitive.
So that's what we're left with. We started with what looks like just a tail, and we ended up finding evidence of a complex, specialized brain. It really makes you wonder, doesn't it? If a behavior that seems so simple on the surface holds this much complexity, what other incredible secrets are just waiting to be discovered in the animal kingdom, hiding in plain sight?